working principle of simple loop generator. So working principle of simple loop generator, దీని గురించి చెప్పాలంటే ఫస్ట్ we need to some Faraday's laws. Faraday's laws. What is the Faraday's first law? What is the Faraday's first law? Whenever a conductor cuts the magnetic field, the EMF will be induced into the conductor. So these are the Faraday's first law. So this law is also known as the dynamically induced. This is nothing but the dynamically induced EMF. This is nothing but the dynamically induced EMF. What is the dynamically induced EMF? E is equal to BLV sin theta. So B is nothing but magnetic flux density, length of the conductor. V is the velocity in the sense of speed of the conductor. Again, theta is nothing but, this theta is important, theta is nothing but angle. This angle is nothing but, for example, theta is equal to 90 degrees and theta is equal to 0 degrees. So theta 90 or 270 or 270. Here theta is equal to 0, 180, 360. So they are the repeated. So in this case, for example, theta is equal to 90 degrees. So when theta is equal to 90 degrees, induced EMF is maximum. So induced EMF is equal to sin 90 is equal to 1. So induced EMF is maximum condition. So when theta is equal to 0 degrees, theta is equal to 0. So that the case of induced EMF is minimum in the nothing but, so approximately it will be 0. Okay, so let us here 90 degrees condition EMF is maximum. So EMF is maximum condition were taken to the two classes. One is linkages, rate of change of flux linkages. When the rate of change of flux linkages is more, induced EMF is more. So first one is, that is nothing but change of flux linkages. First one is change of flux linkages, this, and second one is the flux linked with the coil. Flux linked with the coil. These 2 points. When it is a 90 degrees, induced EMF is maximum. Induced EMF is nothing but, what is the Faraday's law? Whenever a conductor cuts the magnetic field, cutting flux is maximum. The cutting flux is nothing but the change of flux linkages. Change of flux linkages is maximum. It is maximum. Change of flux linkage is maximum, induced EMF is maximum. At the same condition, flux linked with the coil. Flux does not cutting with the coil. Flux linked with the coil. When it is the flux linked with the coil, so is minimum. These two conditions, so induced EMF is maximum. When induced EMF is 0, change in flux, change of flux linkages is minimum, and flux linked with the coil is maximum. Flux linked with the coil is maximum. For example, so these are the conductor, they are the magnetic lines of force. So magnetic lines of force, maximum cutting with the coil, here cutting with the coil. So that the condition is, so flux linked linkages, change of flux linkages is maximum. So if it in case of maximum flux is passing through the conductor. So when the through the conductor flux maximum through the in this area. So at the maximum passing through the conductor, that is nothing but the flux linked with the coil. When the flux linked with the coil is minimum, so that the condition is EMF is maximum. So EMF is maximum, change of flux linkages is maximum. So at theta is equal to 90 degrees, at theta is equal to 0 degrees. It is repeated in theta is equal to 270 degrees, it is repeated in theta is equal to 180 degrees and 360 degrees condition. So when theta is equal to 90 degrees, that is nothing but conductor and magnetic flux both are in perpendicular direction and here parallel direction. So which one is conductor? Conductor is nothing but that is or coil. The conductor is also known as coil. Coil is nothing but the two conductors. So conductor or coil, conductor in when first theta is equal to 0 degrees, for example. Conductor coil in parallel with the magnetic flux. In parallel with the magnetic flux at 0 degrees. So at 90 degrees, conductor perpendicular with the magnetic flux. Okay, so these are the basic things of working principle of simple loop direction. Another one of the basic things Fleming right hand rule. Another one of the basic thing is Fleming right hand rule. So what is the Fleming right hand rule? Right hand use it for the generator, left hand use it for the motor. So one is the thumb finger, that is the Fleming right hand rule. Fleming right hand rule. Thumb, forefinger, and this is the middle finger. Middle finger. So thumb indicate first. So here forefinger indicate the magnetic lines of force. So magnetic lines. And thumb is indicate the rotation of the conductor. So rotation of the conductor. Conductor rotation. Here we are taking the conductor rotation is anti-clockwise direction, that is the counter-clockwise direction. So next one is the middle finger. Middle finger, it is induced EMF. So nothing but induced EMF or like as a current. Induced current. So these are the Fleming right hand rule and Faraday's law and how to behave the conductor at 0 degrees, at 90 degrees. What is the induced EMF maximum? Maximum is nothing but change of flux linkages is maximum at the same condition. Flux linked with the coil is minimum. Okay, at 0 degrees, change of flux linkages is minimum and flux linked with the coil is maximum. So let us we go to the simple loop direction. So first we are consisting of only slip rings. We are taken only slip rings. What are the slip rings? Slip rings. Slip rings are rotating into the coil. What is the coil will be rotating? In slip rings also rotating in the same direction. So slip rings is rotating with respect to the coil. Coil ఎలా అయితే రొటేట్ అవుతుందో స్లిప్ రింగ్స్ కూడా అలాగే రొటేట్ అవుతాయి. సో ఇవి ఎక్కడ స్పేస్ అవుతాయి? ఆన్ ద షాఫ్ట్. ఈ షాఫ్ట్ పైన స్పేస్ అవుతాయి. సో రెండింటికి అవుతుంది ఇన్సులేటింగ్ టు ఈచ్ అదర్. So both the slip rings S1 and S2 are insulating to each other. So next one is the brushes B1 and B2. B1 and B2 are brushes. So ఈ brushes ఎలా ఉంటాయి? ఫిక్స్డ్ ఉంటాయి. So these brushes are fixed. So next one is R. So let us say R. R is nothing but external resistance. R is nothing but the external resistance. Okay, so these are the basic things of working principle of simple loop. So let us we are taken to the how to produce the AC and how to produce the DC. Okay, step by step. First we are consisting only slip rings. Slip ring concept. Slip ring concept. Output we producing the generally armature is producing. So there are the field winding, there are the armature winding. Armature winding is placed in the coils. So armature is generally producing the AC current armature. So positive and negative. So let us 0, 90, 180, 270, 360. 0, 90, 180, 270, 360 degrees. First let us take into the case 1 at 0 degrees. At 0 degrees what happened? At 0 degrees is nothing but coil in parallel with the magnetic field. So what is the parallel condition? Induced EMF, whatever the induced EMF is 0. Why? Linkages flux and flux linked with the coil. Linkages flux is minimum, linked with the coil is maximum. So that's the condition. The condition is here applicable. Whatever the condition writing, so the condition here applicable. So at the condition what happened at 0 degrees? Induced EMF is 0. Next, so it will be increasing from 0 to 90 degrees. When it is a 0 to 90 degrees, so the current, whatever the induced EMF is increased, the current induced EMF is increasing direction. Increasing. So up to 90 degrees. So there is the case 1. Let us case 2 at 90 degrees. At 90 degrees. See here, case 1, for example, we are taken to the case 1 direction. So the current is always flowing from 2. Here A, B, C, D. So the current flowing direction is current direction. Let us current direction. We are taken to the current direction. Current direction. Current direction is A, B, M, L, D, C. So they are the current direction loop. Current direction loop. So the current flowing from here M to L in this direction. So positive direction. Let us at 90 degrees. Case 2. Case 2 at 90 degrees. What do you mean at 90 degrees? So both are in, which is coil and magnetic field are parallel, perpendicular. Coil and magnetic field are perpendicular direction. When it is a perpendicular direction, induced EMF is maximum. Then next 90 to flowing from 90 to 180 degrees. 90 to 180 degrees, what happened? The induced EMF is decreasing. Now starting to the decreasing. So the current flowing direction is never changed. The current flowing direction also, the current loop direction also same. A, B, M, L, D, C. They are the loop direction. No change. But now case 3, we can observe the case 3 at 180 degrees. So 180 degrees, again it is a parallel condition. The coil in parallel with the magnetic field. Coil in parallel with magnetic field, whereas induced EMF is 0. Here clear. So let us 180 to 270 degrees. What happened? Induced EMF is increasing in negative direction. In negative direction. Nothing but the current loop direction here. Current loop direction. Current direction. Current direction. So the current direction will be changed. The coil will be rotating. So C, D, A, B. Okay, it is nothing but again it will be reverse direction. That is nothing but okay. C, sorry, it will be reverse. A, B, C, D. So it will be reverse direction. C, D, L, M, B, A. The current flowing in opposite direction. Here, current flowing is opposite direction. So, the condition is reverse direction. So, output is coming from the negative field direction. So, here current is opposite direction. So, therefore, output result on this where it is slip rings. Output from the, let us again, output from slip rings. Output వస్తుంది స్లిప్ రింగ్స్ అవుట్పుట్ ఏసీ ఆల్టర్నేటింగ్ కరెంట్. ఎప్పుడైతే నేను స్లిప్ రింగ్ తీసుకుంటున్నా అవుట్పుట్ నాకు ఏసీ కరెంట్ వస్తుంది. సో లెట్ us హియర్ కేస్ 4 it is similar to case 2, but only what is the change? Direction of current will be changed. Current direction is change. So the current direction is CDLMBA. The current direction is CDBLA. So remaining case 4 is similar to case 2. Here case 2 is nothing 90 degrees is replaced with at 270 degrees. That is the changes. So what is the output? Slip ring output is AC. Output current is AC generated. But we need to DC. Output is producing to the DC. They are the DC generator, not for the AC generator. So అప్పుడు ఏం చేయాలి మనం AC generator place లో in DC generator ని కన్వర్ట్ చేసుకుంటాం. అంటే ఏం చేయాలి? Just only we can change the slip rings, split rings replaced with the split rings. ఎప్పుడైతే నేను split rings వాడుతున్నానో so we are used for the split rings. So first split rings ఎలా ఉంటాయంటే ఒక సిలిండర్ షేప్ లో ఉంటుంది. సిలిండ్రికల్ షేప్. In between some insulation, mica insulation. This insulation is mica insulation. So this is SG1, SG2. అంటే ఒకటే split ring is split into two segments. So split rings split into two segments. So the two segments are SG1, SG2. So these are connected to the coil. These two are the split rings. It is connected to the coil directions. So with respect, it is rotating with respect to the coil. It is similarly, it is rotating with respect to the coil. Coil to part rotate అవుతాయి. So remaining these are B1 and B2. So B1, B2 are brushes, again same. So in between two segments, in between two segments, so some insulating material, they are used from the insulating material. So that insulating material like as mica we are taken to the some insulating material mica. So in first case 0 to 90 degrees. Again 0 to 90 is maximum, directly we are taken to the 0 to 180 degrees. In 0 to 180 degrees the coil will be shifted to the coil rotation here first 0 to 180 degrees. First we are taken to the 0 to 180 degrees. Directly we are consisting 0 to 180 degrees. So B1 brush 1 is connected to the segment 1, commutator segment 1. So let us it is connected to the positive terminal. Positive terminal. It is connected to the positive terminal. So B2 we are taken to the B2. Yes, Z2 it is the negative terminal. The current flowing direction. So we are taken to the current flowing direction positive to negative or negative to positive. The current flowing from the negative to positive direction. So in this case the current loop direction we are flowing from the internally negative to positive, externally positive to negative direction. So let us external direction is positive to negative direction. Here current direction is positive to negative. So let us be taken to the again in this direction only, M to L direction only. After we change to 180 to 360 or 0 degrees. So here from in this case automatically which one coil, whatever the armature coil, armature is always producing to the AC. Armature always note armature produced AC current, alternating current. So alternating current is nothing but, sorry for the interruption. So B2 and armature winding always produce the AC. So next 180 to 180 degrees to 360 degrees. So B1 is connected to just this SG1, SG2 will be interchanged. So remaining positive terminal, negative terminal. So current direction will be same direction. So the current direction is same in this direction. Whatever the first case 0 to 180 degrees direction, whatever the current direction, the similar current direction will be occurred into the second case also. So B1 SG1 to positive terminal, B2 SG2 to, sorry, here small mistake. 2 and 1. So these are interchanged. 2 and 1. So B1 is positive, B2 is the negative. The current direction always flowing to the same direction. So we can take it as positive and positive. They are the only single conductor, single coil. If we are taken to the number of conductors, when it is taken to the number of conductors, automatically what happens? The resultant is pulsating DC. So to avoid the pulsating DC, so we increase the number of conductors. We increase the number of conductors automatically to avoid the pulsating DC. So when it is number of conductors will be added, so it is formed to pure DC form. So these are the working principle of simple loop generator. So next class